this is called a vacuum and nitrogen line, right? So you see, one needs to pay attention to this being closed, because if you open it, of course you let air in, right? This is connected to nitrogen, and this is a security valve to keep pressure but to let nitrogen out if the pressure goes up so that it doesn't explode. Oh, you see what I mean?
Yes.
Right, and this is Vaseline oil for air not to come in and for us to see it slightly bubbling to know there is pressure inside the line. Right? Ready? Good. So now, may I have the second diwa? So we put it there. Now we switch on the liquid nitrogen to this diwa in order to make a cold trap. Cooling down the glass, but all the heat it's taking from the glass makes nitrogen boil. That's why it's coming out. And there's a moment when the temperature balances, reaches. So now, you may imagine that any vapor that we absorb, that we aspire from here, when it gets there,
Turns liquid.
solid,
Solid.
because it's
Really
almost
cold.
200 degrees below zero, right?
Yeah.
So what is this used for? And now I'm going to open nitrogen. Let me please. Word, right? Quick fit. And you need to put Vaseline for two things. One, for it to adjust well enough so that air does not escape or does not come in. The second reason, which is also very important, is that it fits very well. And without Vaseline, it could just get stuck, and you'd hardly be able to separate it afterwards. Thank you. The way to use it is you get a rubber band, right, which adjusts very well. Now we have a little water in here at more or less room temperature. I've held it, but more or less room temperature. Yeah? If it were a air-sensitive substance, which is not this water, we would first, with the tube closed, we would first make vacuum. Have you heard? Yes. And then we would put nitrogen. Listen. When you are in the lab working with these materials, your ears are extremely useful, right? But in order for you to be able to hear anything, there must be silence, right? Listen, and you will hear vacuum being made. Have you heard it?
Yeah.
And now we are going to put nitrogen again. Now what we have here is nitrogen. There's no oxygen left. There's no water vapor left from the atmosphere because we've aspired it, and then we've put nitrogen instead. So if this were sensitive to air, to oxygen or water vapor, we could already open this tap without danger. Right? Good. So now, again, what we have here now is water. Yes. Now, what do I have inside the rubber? Look. Where is it pointing?
Up.
Up, meaning? It's making vacuum, right? If I open this tap, what's going to happen here?
It's gonna come in.
We are going to aspire the air here, right? And pressure is going to go down, right? because we're going to aspire gas, right? And look what happens. Listen. Water is boiling. Can you see it?
How can it be boiling?
Because pressure is very low. Right. So now I'm going to put nitrogen instead. And now we can open it. But before opening it, I'm going to prepare the equipment I need to use. There was
Adding nitrogen.
letting nitrogen in, right? But it is above atmospheric pressure. That's why it comes out, right? It's blowing, right? So if we open this, what's going to happen?
It's gonna.
Well, not that much, but nitrogen is going to come out. If this were sensitive to air, since nitrogen would be coming out, oxygen would not get in, right? Because you have a flow outwards, right? So first, we put some Vaseline on the male fitting. We already have it here, but I'm going to put a little bit more just to ensure we don't have problems. And I want there's in each set of equipment there's a rubber band with are they at the end? A piece of rubber that exactly. Thank you. Yes, and I need the sensor, the pressure sensor, and the interface. Can you please connect it? Pressure sensor. And look, now it's showing the pressure. It's more or less 1.5 atmospheres. It's actually a little bit too much, but. And now we have atmospheric pressure, a little bit over 100,000 pascals, right? We connect it here.
It's like a screw, isn't it?
Mm-hmm. And it fits. And now we open this. We will hear nitrogen going out. Put the cover and then
Why don't you
in my hands, which is easier. I close here, I make vacuum, and now carefully, hand in carefully, I open this. And you will hear vacuum being made. Can you hear it?
Yep.
Now there's no risk that this goes out. And we can see, we should be able to see water boiling again.
Does it have any boil?
Because the pressure is so low.
Because when there is less pressure, the volume increases and the temperature goes up.
Like if we stretch if we stretch various times the rubber band.
Right. And now I'm going to close it here, and we're going to see what happens. Can you please give me another tube with another cover and another set of a sensor actually with another computer, the whole thing. Computer, interface, and everything. No, I need the glass. We've created vacuum. And now I'm going to close, right?
Did the pressure be at 0?
Well, it's not perfect 0. And I think it needs some adjustment. But what I want you to see now is we've made vacuum here, we've made vacuum there with the same pump, right? Can you please look on the screen the pressure? Both.
32 kilopascal.
0.32 and here
5.50.
what is the reason for that difference?
Water.
What is the effect water has?
It adds volume.
We are measuring the gas pressure inside the tube.
Oh, water has gas.
What do you mean?
Oxygen and not oxygen and hydrogen.
No.
Water, I mean, water hasn't evaporated. Water is a liquid, so I mean, it does reduce some volume.
When there was vacuum, the water boiled, so some water evaporated. So there was